So exercise 17 here, we're kind of ending these chapters exercise problems on a very simple one. Definitely not as difficult as some of the ones that we've done above here with the for loops earlier and stuff. But it's a very simple one, and it's more about using the math module. So we should know by now that if we import math, we can print the value math.pi to get a super good representation of pi. And it prints out to this much, but functionally it's better, arguably, than most other approximations of pi that we would. And it's asking us to go ahead and go and search the internet for an approximation for pi that you can a calculation of a pi approximating. And before we how to calculate pi very well, we use these approximations, these easy approximations for pi in calculations for a very long time. And we know that a lot of people, when they want to use pi, will just use 3.1, which is fine. It's close, right? 3.14 is close to pi. And another common one that you see a lot is 22/7. That's a very common approximation for pi. And that one is good for most cases. Not working on super detailed work, or you care about getting it down to super small fractions of a decimal, right? Let's see what those result in. So 3.14 is obviously just gets us 3.14, and 3.22/7 obviously gets us something that's still good for the 2 decimal points here, and then kind of drifts away, though, because this one is almost 16 thousandths. Is that no 16 10,000ths of away from the 3.14 rather. It's like 16 thousandths here away from the actual good value of pi that we have here, whereas this one is technically only about 13,000. So this one is actually pretty close, much closer. But if you search the internet, you probably found that the best small fraction value approximation for pi is actually this fraction here. You have to go out to much bigger numbers in order to get a better approximation for pi. Let's run it and see, and here we get 3.14159292035 versus actual value of pi that we have from the math module, which is 3.115925359. And so you can see we get, with this approximation of 355/113, we get out to 6 decimal places before we have to start diverging from the actual value of pi. And even then, we're only going off by 3. What would that be? That would be 10,000, 100,000s, millions. We're off by 3/10 millionth of a whole digit, a whole number from the actual pi value, which is pretty good, right? It's pretty close for most things. 6 digits of approximation there is going to get you pretty dang close to pi. So this is a good one. This is a good one for most cases. This one is in a pinch will do. Just 3.14 in a pinch will do. But even just using 3.1415 would be better, remembering those extra couple digits. But if you need to use fractional whole number division here in order to get your pi approximation working right, then you can't do much better than 3.5/113. Let's talk real quick about the weekly graded assignment. It's very easy. It's asking you to write 2 loops that print a series of numbers. So assume you have this list of numbers, write a loop that loops through it and prints each number, and then write a loop that loops through it again and prints each number and its square in precisely this format. So if you've read the chapter, if you've done exercises, this graded assignment here should take you 2, maybe 3 minutes in order to complete. Definitely not as hard as chapter 3's graded. So get to it. Write these 2 formulas. I know you can do it. I know you can do it and knock it out real quick in only a few lines of code, because you're code wizards, and I believe. I will see you in the next chapter.